All right, let's talk about machine learning. You've probably heard the term a million times, right? But for a lot of us, it kind of feels like this mysterious black box. Well, today, we're going to crack that box wide open and see exactly how computers actually learn.
So here's the big question, the one that really stumps people. How in the world can a machine learn from its own mistakes? Without a person having to go in and rewrite the code every single time. It sounds a little bit like magic, doesn't it? A computer that just gets smarter by itself? Well, that's the mystery we're diving into.
And this is what we mean by the black box. You feed some information in one side, a decision pops out the other, but what happens in between? It's a total mystery, or at least it feels that way. But the key to unlocking it is actually surprisingly simple.
To really get a handle on this, we're going to do something a little different. We're going to forget all about computers and code and data centers for a minute. Instead, I want you to picture a chef, a really good chef in their kitchen. Trust me, this is going to make everything click.
Okay, this is it. This is our key to understanding the whole thing. We're going to map the computer's world right onto a chef's kitchen. You've got ingredients, a recipe, and the final meal. Simple, right? So let's walk through what each of these really means. So first up, we have the ingredients. In the machine learning world, that's your data. This is all the raw stuff you have to work with. Sales numbers, weather reports, you name it. And just like with cooking, the better your ingredients, the better your final dish is going to be. It's that classic saying, garbage in, garbage out.
Next, every chef needs a recipe, right? Well, for a computer, the recipe is the algorithm. It's just a set of instructions. It's the step-by-step guide that tells the computer exactly how to mix and combine all those ingredients, all that data, to create something new.
And that brings us to the final meal. This is the output. It's the finished product. In the computer's world, that final dish could be anything. A prediction of what you'll buy next, a recommendation for a movie, or even just sorting your emails. It's the delicious result of the ingredients and the recipe working together. But here's where it gets really interesting. Because let's be honest, the first time you try a new recipe, it's never perfect, is it? So what does a great chef do? How do they improve? This single question is the absolute secret to how machines learn. They do it through what we call a learning loop. It's a really simple four-step process. First, you cook the meal, you make a prediction. Then you taste it, you compare your prediction to what actually happened. Next, you adjust, you figure out what went wrong, maybe it was a bit too salty. And finally, you improve, you tweak that recipe for the next time around. Cook, taste, adjust, improve. That's the cycle.
And that taste and adjust cycle? That's it. That's how a computer learns from its own experience. It's not magic. It's just repeating that loop over and over and over, thousands, maybe millions of times. Each time it gets a tiny bit better, a tiny bit smarter, without a human ever writing a single new line of code.
Okay, that's the theory. The chef analogy is great, but let's make this super practical. Let's see how this whole process plays out for a real-world business right here in Canada.
I want you to imagine a clothing store, say in Saskatoon, and every single year they have this massive problem. If they order too many winter coats, they're stuck with them. If they order too few, they lose out on sales when that first blizzard hits. It's a classic business headache, and it's the perfect job for machine learning.
Now look at this. This chart shows the learning process in action. The first year, the computer makes its prediction, its first meal. And you can see, there's a pretty big gap between what it predicted and what actually sold. It tasted that result, learned from its mistake. And then look at year 2. Wow, the prediction is so much closer.
So what exactly happened there? Well, the machine took all the real-world sales data from that first year. That was its feedback, its taste test. And it used that information to automatically tweak its own internal recipe, its algorithm. The result? A way smarter, way more accurate prediction for the next winter. And for that business, that means less wasted money and happier customers.
So, we've gone from the kitchen to a Canadian storefront. We've seen all the different pieces. Now let's just put it all together and look at the entire workflow from start to finish.
And here it is, the whole shebang. You start with your input. Those are your ingredients, like past sales figures and weather data. The algorithm gets to work and processes it all. Then comes the most important part, the learning, where it compares its guess to reality and adjusts itself. And finally, you get your output, a much better forecast ready to go for the next season. That's the engine of machine learning. So, what do you really need to remember from all this? First, don't let that black box scare you. Just think of a chef. Remember that data is just the ingredients, and the algorithm is just the recipe. The real magic is that it learns by comparing its output to a real-world taste test. And it's this simple idea that's helping businesses all over Canada make much smarter decisions. So we've cracked open the black box, and what we've found inside isn't magic. It's just a process, a really powerful one, which leaves us with one last big question to think about. Now that we know how to teach computers, what's the next great recipe we should be teaching them to help us solve? Thanks for tuning in.